Hello everyone and welcome to another webinar from K2 Systems. My name is Kyron. I work in our technical sales department here in Renningen in the south of Germany where we are experiencing a lovely autumn day, and I hope it's the same with you too. Today we're going to be going through the electrical side of PV, not necessarily the power production, however the equipotential bonding and also the lightning protection. So to be honest, I'm sure you're all aware of that. You've signed up for this webinar, so let's not spend too much time talking about that. Before we get started, I would like to just point out that we have put a little quiz up. We really appreciate your feedback because it helps us know who we're talking to, specifically you, and we can better tailor the information that we are going to give today and maybe go a little bit more detail into one side or the other. So if you haven't already filled out that quiz, we would really like to appreciate it, or we really would appreciate it. If you have any questions throughout the day, we would also love to hear them or see them, especially in the Q&A function. So down the bottom of your screen, down Zoom, you'll have a chat function button and also a Q&A. Depending on your language settings, it might be a different letter combination, but generally speaking, meaning question and answer. And in the questions posted in there, we'll be able to be seen and easily answered by two of my colleagues who are helping me today, which brings me probably into introducing them. So we'll be joined by Martin and Nicholas today, who are experts on the system. I'm going to put it out there and say that. Martin, Nicholas, maybe could you have say a little welcome and a few words about yourself, please?
Yeah, hello together. My name is Martin Riedel. I'm part of technical sales at K2 Systems, and since 2006 in the photovoltaic, and since 2016 at K2 Systems. And today, me and Nicholas were working in the background, and we'll try to answer your questions. And so, Nicholas, perhaps you can say some words for you.
Yeah, sure. Hello, my name is Niklas Willmann. I'm as well in the technical department of K2, and I'm supporting the colleagues of K2 since July this year. And I've already a lot of knowledge in solar, so I hope I can answer your questions properly.
Okay, I'm sure you both will be able to help us quite a bit in today. So if you do ask any questions, they will usually be, or they'll mostly be answered by one of those two, who you might have seen up here or over here, depending how your Zoom is set up. However, they may also just ask that we can talk a little bit about it. So we have a few products here. This will be that I'll be showing as well. So if you do have some questions about, hey, could we look at this product a little bit more, put them in the chat, put them in the Q&A section as well, and one of the guys will just let me know and I'll be able to go into it in a little bit more detail. Okay, I think then we're probably about done with all of the housekeeping. We're going to go through a bit of a presentation and then jump back to here and then back to a presentation. So I think we're going to start off with that. And I will just share my screen. So please let me know, or I'll just get a thumbs up from Klaus behind the screens that the screen's now being shared. And so today, obviously, we're talking about equipotential bonding and lightning protection. And, oh, sorry, let me just jump now to my next slide. And the reason we're doing this is, well, one of two reasons. The first one is we get a lot of questions about it, and so obviously we want to provide a broad piece of information for you to learn a little bit more. Also, this video will be recorded and sent out to you all later and probably put up on YouTube as well. So the idea is we can provide or answer many questions with this one video, but there is also some, let's say, issues with the topic or in areas that are a little bit unclear. And hopefully we would like to provide a little bit of clarity or at least our perspective of some technical literature that doesn't always match up or in some cases overlaps a little bit, and hopefully make that a little bit more or a little bit easier to understand for the wider audience. Before we get too far into it as well, I should also say that this presentation is based on the German technical standards, and they're not a one-to-one for all of the other countries in the EU. So we highly recommend that you use this information as general information, and please revert to the national standards of whatever country you're in. The reason we've done this is most of we're a German-based company, and a lot of our work comes around that. So the German reference is our main reference, and just be aware if you're taking some of this information that it may be a little bit different into the country you're working in. Even as a little example, this morning we did it in German, and there was a Swiss customer who knew the standards were a little bit different in Switzerland, and mentioned that to everybody, shared it with the group as well. So that was actually really good. And furthermore on that topic, if you do have or we are going to plan any projects to do with lightning protection or equipotential bonding, we also highly recommend that you get a specialist involved, and we'll talk a little bit about that later and highlight it through the presentation. So we're going to go through the two parts, or break it up into two sections, I should say. So our equipotential bonding and earthing will be our first topic today, and then our lightning protection as the second topic. And they do overlap a little bit, and you'll see this throughout the presentation, but just so you're aware of what we'll be going through today, it's shown on this slide. And here's just a little picture of an earthing on a tile roof. You can see some of our products here as well. So what is the kind of difference between this? And for some of you, this may be really basic topic, but let's just start at the very beginning so everyone's on the same page. So if 2 points, doesn't matter what they are, if they're in the PV industry or anything else really, if there are 2 points that have a different potential, and they are connected conductively, then these 2 points are termed to be equalized. All right. And then if this connection is then taken again to the ground or to the earth, as in equalized with the earth, this term is then called earthed or earthing, or taken to ground. All of these terms are a little bit synonymous or interchangeable in this context. The main reason we want to we take things to earth is to prevent against electric shock. So this doesn't necessarily mean electrocution, but just a small shock. And if you've been on a long drive, sometimes you get out of the car and you get that little zap on the door, for example. It's because part of the car or yourself wasn't earthed, and the other part was. And there's a little shock that's running across. And if we can avoid that occurring on the PV systems, we're creating a safer system and a safer workplace for everyone. So that's probably the main point here. And you can see that we have the personal protection listed. And as part of the VDE 0100, which is the German institute that effectively sets up or has a big influence on the German standards, they say that for any PV system, earthing is required if there is any conductive touchable points, right, which are going to be very regular when you're installing a PV on a roof. Jumping now to a bit of terminology. So I know there's a lot of information on this slide, and I'm going to summarize it quickly because we will send the video out, and we will also send these slides out later as well, so you can look at it in a bit more detail later. Some of the terms for earthing, we have the equipotential bonding, which, as I said before, is between 2 or more objects. And we have earthing, which is between those objects and the ground. And we also then have 2 areas or reasons for why we would do this. One is in protection. So this is to stop shocks occurring or arcs occurring and prevent any form of injury or damage occurring to property. And the other part is a functionality. So potentially the system it has required this earth or this equipotential bond to be able to work properly. So moving this then into the PV frame of things. So what can you earth with PV modules? The frame is effectively one of the only things you can earth. And the question then is, do they need to be earthed. And this is where sort of the confusion or the uh, area of uncertainty or where it's not clear comes up, because all modules on the market in the European market, in fact, all electrical products on the European market come with a CE administrative sign or administrative stamp. And this is a stamp of approval, which means that the product has met all of the requirements stated by the standards. All right. So in the case of the module, it's saying that it has met all of the standards set by the the requirements set by the module standards, and one of them is to have a protection class 2 in the system, or the sign off that it has to be done. This is now not necessarily meaning it's a level of quality, but it's just to say it's all been ticked off and met the appropriate uh, requirements for the system. And what's interesting about it is that for a product, electrical product with a protection class 2, it says that a earthing conductor is not required, and it's also not permitted on such a device. So on one side of things, we have saying it's not necessary and not required. However, there is exceptions for functional earthing, and this is when module manufacturers may themselves say, no, this product needs to be earthed, or there needs to be an equipotential connection. And here we have an example of a JA solar module where they explicitly say that the module frame should be connected to the grounding conductor to prevent thunder or electrical shock. So just with these two, there is a little bit of conflicting information there, but it goes even further when we look at some other aspects of it as well. That was the functionality side of things, but there is then also the protection side of things, or the protective side of things. And in this part, because it is this protection class 2 from the CE standards, it doesn't need to have an equipotential bonding. However, the International Electronical Commission, which is the IEC, which you can see here, states that the frame of the module is not actually part of the electrical production, and it is merely a supporting component or an auxiliary component to the PV generation. So against this background, we can actually say, well, the PV generation is the laminate and the cells inside the laminate, and the frame is a separate product, which then can be earthed or can be ground to ensure that personal protection is maintained and to stop people from getting shocked if they're on the roof. And this wording gap, or this understanding between the different parties, is now something that's utilized across a lot of the PV industry and recognized by quite a few major bodies within the industry as well. So this was the functionality and the protection side of things, but there is more topics that come into it as well. And one of them is the concept of potential-induced degradation, or PID. And this is a voltage-related power degradation of PV modules, which can be caused by a leakage of currents, and this can have an effect on the modules up to about 30% in terms of its how it's using, or how it's producing energy. It usually occurs where there is a negative voltage to the Earth's potential. So if the system, whether it be the frame or the whole PV system, is at a negative potential to the Earth and is accelerated where there is a high voltage difference, high temperatures, or high humidity. And to take that further, or more specifically, for systems that are above 1,000-volt systems, it can be really important for the modules themselves that they will be earthed or they are earthed on part of their functionality. And most systems today are usually between 1,000 and 1,500 volts in how they operate. There are some, but from what we've found, only a few modules that explicitly say that they are PID resistant. And if this was the case, or if you do have a module that says this, and you'd see this in the module database, module data bank, sorry, or maybe in their assembly instructions, that there'd be no grounding or no connection necessary. However, from the ones that we've seen, this is very, very few. So what do we recommend in terms of this? Unfortunately, that most of the module manufacturers are quite vague in terms of their requirements for earthing, whether it be a frame earthing or not. So our thoughts are, or our recommendations are, if module frame earthing is explicitly stated as unnecessary, then no need to earth it. However, if it is not stated at all, then we would recommend using some form of earthing to the module frames. All right. When you try to include lightning protection, and this isn't the start of our lightning protection section, but if you look at the module frame earthing in the concept of lightning protection, things change a little bit as well. And if you were to interpret the lightning protection standards, which are different to the standard electrical documentation, then the module frame has to be earthed as soon as the PV system is integrated into a lightning protection system. And the idea of this is to prevent any sparking, which effectively then prevents any, or hopefully prevents any fire from occurring. One of the best ways of doing that is with the sort of a 6mm cable, which you can see here, but there are a number of ways you can do this as well. We're going to go through that in a little bit more detail. Just on the cable actually as well, before we move on, it's not yet a rule, but it could be something that comes in the future, is that this cable has a 6mm cross section, and it must be, the sole purpose of this cable must be for the electrical connection. So it's not allowed to have any mechanical properties or mechanical role within the system. So how do we go about doing either earthing or this equipotential bonding for a system integrated in the lightning protection? So it is generally recommended that for protective equipotential bonding, that there is a green and yellow cable used. However, this is not 100% necessary. And on the flip side, if you have a functional equipotential bonding, this must not have a green and yellow cable. So to be safe, you could always have no cable, green and yellow cable, and this would meet the requirements of one and the optional extra of the other. In fact, for the connection that we have here, there is actually no color coding that is required as per the German standards. What is more important is the mechanical properties of the material as well. So whether it be a copper wire or an aluminium wire, that you then need a different cross-sectional area. And notice here that we're talking about the cross-sectional area and not the diameter. So easy way to find some of this information, off the top of my head, actually not off the top of my head, I think I've written in the notes here, or maybe on the next page actually, that a 4mm diameter, let me just jump back, 4mm diameter is approximately equal to 12 millimeters squared. So you can just use that as a bit of a reference, but also there's a lot of information on the internet, I'm sure, on how to calculate that difference. There is a number of other components that you could use as well. So this includes module clamps where they have a mandrel or a little sort of tooth built into the clamp itself, which ensures that contact. The TerraGriff, which is our K2 product, and there are some other possibilities as well. Let me just now jump over to the next page. So this is one example, and this is the example from K2. And we would like to give a bit of a general presentation of today, but we also would like to show one example of how you can go about providing this earthing or equipotential bonding as well. And this is the one we know because the one we have on hand. So in a situation like here, you can have aluminium or copper, which is shown here. This is a little setup with our lightning protection set, which you can up here with the lightning protection set, which you can see down below in all the parts. One thing to be aware of as well, so copper and aluminium are two metals that are not the most favored to be in contact with. So if you are going to have a connection between a copper section of a wire or a copper something and an aluminium product, there is a strong recommendation or maybe even a requirement to use some form of lug, which is specially designed to create a barrier. So whether it's a sintered or a stainless steel, doesn't really matter, but use a requirement that the two metal types don't come into direct contact. So this aluminium cable here as well, this is something that we sell, and so this is an 8mm diameter, which is approximately then 50 square millimeters, which you could argue is a bit of overkill, as the minimum we need is 16mm. However, to clamp it specifically, as in have a product that holds it tight, and also on parts of just availability of products on the market, it's something that we decided that it was a good decision to go down this path and have a wider cable or a wider, larger cross-sectional area cable than the minimum requirement for the industry. Some of the other products we have as well are the TerraGriff. So these are the products that will take the module frame to the rail, and then the rail can be earthed through, for example, the lightning cable or some other products that could be on the market. We now have a bit of an overview of the TerraGriffs, which are on the screen, but I'm just going to give a quick demonstration of how some of them work as well. So let me just stop sharing my screen. I might have some water as well while we jump over to the other camera. Hopefully we don't spill it everywhere. So some of the products that we have, and you saw them before, we're just lying now in front of me. And generally speaking, they act in the same way, or they have the same purpose. That all of the products have some little teeth on them. So you also have to be a little bit careful if you're rummaging around within a bag, because they are quite sharp. And the idea is behind all of these little teeth is to scratch the surface of either the rail, which I have behind me, or a module frame, and ensure that there's an electrical contact between the two. Reasons being that the aluminium and the module frames as well can build up an oxidized layer, and we want to scratch through that and ensure that there's a connection. So we have quite a different range, and that's because we have a few different products, and one of them is used for our 1 mid 1 ends, which I've just popped in here, and maybe Klaus, we can spin around. So this is our this is our K2S Z, and for this one, for our middle clamps, they're just going to sit on either side, and generally speaking, we need one of these per module, right? So I have two here because this is a middle clamp, so I'm going to put a module on each side, and you see that they're a little bit springy. So if you just lie it in, it's not going to do anything, and I've actually just had to push that in. We then put our module in as so. Maybe I can, or even from the other side. right? And as I tighten from here, these little teeth are going to be pushed out and scratched into the module frame, right? And then I have little teeth on the inside of the pteroglyph, which sits inside the channel, and these will scratch into the rail, and so our rail and our module can now be deemed at the same potential, right? So for the different clamps and the different situations, we have slightly different products. So let's take that one out. For our new MK2 clamps, I'll just put that in the rail. We have a different pteroglyph which acts as effectively the same principle. There's little teeth on it. There's the teeth at work on a little bit different sides. So in this one, you can see the teeth are on the outside of the rail rather than on the inside. And again, as you tighten, they're just going to scratch into the rail, and these ones up here will scratch into the module. For our dome setup, we have something that's again a little bit different. So this is our K2MI. Let me just move some of these out of the way. And this sits on our dome. Sits on our dome clamp, and this acts a little bit different because this is just the one product. You only need one of these for the two modules, one on either side, whereas with the pitch groove solutions, you would need two, right? And it slides just into our dome. So I have here our peak for the flat roof system, and it's just going to slide in like so. And the same principle as we push down, we will scratch into the rail. We do also then have one extra one, which is for the rail connector set. So if you're using the express system, then this will clip onto the rail connector set. And then as you put this into the rail end, it's going to scratch into the rail and hold it in place. So most of these are single use. So I'm not going to put it in because it will be quite difficult to get back out. And the idea is then as you're pulling it, it's going to catch, and the teeth are going to bite in, and that connection is going to be sound. So for the flat roof systems, and so if we do have a express system and you want to make sure that the whole rail is at the same potential, these are required for our rail connector sets. If you are going to be doing, or are really concerned about the electrical equipotential bonding and the lightning protection side of things, we would recommend the continuous rail system. So that'll be our LS sets, or our classic, not sets, sorry, just our Dome Classic or our Dome LS, because this way you're going to have less connections, and the connections that are there are fixed in a different way than the Express system. So if you're joining for the first time and you don't know so much about the flat roof terminology, we encourage you to maybe go look at one of the flat roof webinars that we have online. Because we go through all of that in a little bit more detail. But if you do know the K2 range, you would be aware of what we're talking about there. So in terms of our products, I might just show the lightning protection set as well while we're here. So a little bit of cable, and these are the products that were shown. Again, if you know the K2 range, we have a MK2. It sits on, and we're just going to tighten that with our standard screw, and our connection, or our location where we can run the rail, is sort of simply that. We can run this between rails. We can run it maybe between, if there is a rail running this way, this cable can be bent out and connected to a next rail, or a perpendicular rail. The options are quite wide with what you can do and how you can do it with the lightning protection set and the cable that's involved with that. Not just for flat roofs, but also for pitched roofs as well. Okay, so we're going to jump back now to the presentation, and let me just share my screen. Sorry about that. Okay, you should be able to see it in now. Okay, so moving on now to the lightning protection, which has similar aspects but is a little bit different concept as well. We are going to move forward and start off with a bit of basics about lightning protection and terminology for it as well. So generally speaking, there are two types of lightning protection. There's internal lightning protection and there is external lightning protection. What you think of when you see lightning, or what I thought of or think of when I think lightning protection, are usually those little rods that sit up on the roof. And these are what we would call our external lightning protection. So whether it be a conductor or a rod, this is something that is designed to avoid or help avoid lightning strikes, or distribute the load once a lightning strike has occurred, or if a lightning strike has occurred. On the other side, we also have internal lightning protection. So this is if a lightning strike does occur, what happens to the electrical devices, and this is then protected with a surge protection device, or a SPD. And we're going through that in a little bit more detail. But as a general rule, or as a general comment, by putting PV on your roof, you are not increasing the chances of lightning occurring or a lightning strike occurring on that specific roof. So to go in a little bit more detail of these two types, or some of the things to consider when we're talking about lightning protection. So ideally, the protection is of things or people. So property, persons, electronic devices in the house or in the region. And the lightning protection that you see here makes up part of that outside or external lightning protection, right? And in principle, there are lightning protection standards that must be adhered to, but you also have to be quite aware, or should be aware, that in many regions there could be an insurance body or overarching building code for public buildings which provide more stringent lightning protection than the local guidelines. So yes, you'll have the standards, but it's also important to be aware of any information from the public building sector or from the state, or even the insurance companies that may stipulate that you need more or more specific lightning protection on a roof. And one of the probably most important points, or something that we're quite confident to say just for all situations, is that if you do install a PV system on a roof, it should not impact or cancel out the effect of an existing lightning protection. Okay, so that's out of all of the things we're saying today, this is one of the general rules that you should definitely take with you. So if you are planning on doing doing a PV system, and there is lightning protection on the roof, we really implore you to contact a lightning protection specialist, right? Because they are the ones who are the experts in this field, and they're the ones who will be able to provide you with a project-specific plan. And some of this will include things like, will the PV system be integrated into the lightning protection or not? They'll be able to help you with the spacing between the PV system and the lightning protection. They also will have an idea of what sort of surge protective devices are necessary, and should be able to provide most of the information about that. There is a little bit of let's say, an industry-wide issue or area where we could improve that the lightning protection specialists are not necessarily aware of all of the PV features or the components that come into a photovoltaic system. So that's part of the reason why we're giving this presentation today as well, to allow that everyone from the PV industry has a little bit of understanding of how the lightning protection works, and hopefully can then at least ask the right questions of the lightning protection specialists. What is also probably an important point to say for this as well, we would expect or assume that if you are doing a PV project when there's lightning protection involved, that it would very much be a cooperation between the PV planners and also the specialists for the lightning protection. So you can now see a topic that some of you may, or a picture that some of you may have seen before, and it's referring to the protection area and in this case, the rolling sphere method. So one way of protecting against lightning is by effectively hypothesizing or suggesting, imagining that there is a giant ball rolling over the building, and this ball will only touch the top parts of the building. And that might be the lightning rods that's sticking out, it might be the tops of the building, it could be a chimney, but whatever this ball can touch is susceptible to a lightning strike. And everywhere the ball cannot touch is considered the protection area or a safe zone. Actually, I'm going to rephrase from safe zone, but a protection area. So I think safe zone is a bit misleading in terms of what it provides. However, a protection area. So in this case, the PV modules are not being touched by a giant ball rolling across the roof, and so they are then considered in the protection area. And depending on the class of lightning protection required, so if you can imagine this is now a class 3, you would have a sphere of radius 45 that we have up here. However, there is also class 1 to 4, and then this radius changes. And if you have a smaller radius, then you're going to need more of these rods to ensure that nothing can be touched. The main objective of this, though, or of planning a setup like this, is to ensure that the building or the PV system itself cannot be touched by this ball, and therefore is in the protected area or the area of protection. So another part to consider is the shading effect. So obviously, if you put a rod on the roof, it's going to have some shading, and this is going to impact the power output or the energy output of your PV. And as a bit of a general rule, the optimal distance is going to be 108 times the diameter of the radius. And so this is referred to the core shading, which is this middle point here. And depending on your lightning rod thickness, you can take either of these values here, but I also think the ratio of 108 times the diameter is a pretty simple one to follow. The next point, and this is the one that's probably one that has the most confusion or this is susceptible to the most errors, is the separation distance. So this is a little bit different from the protection area because this is talking about in plane, on the roof, what is the distance between the lightning protection and the PV. And there's no general values or rules that can be summarized quickly in this, but there is an equation that can be followed and set up. However, different parts of the roof may have different values that you see here. So as these are coefficients and factors, these might actually change in different areas on the roof. And so the S minimum that you see up here might be different to the S minimum that you see here. And this could even change along the line of a roof as well. So in situations like this, this is why we highly encourage you to contact a lightning protection specialist. There is also software that allows you to do this a little bit more or a little bit better. And so one of them, for example, is the Dean distance tool. So it's DEHN, Dean distance tool, and this will give you a specific value or a bit of a better understanding of what this distance needs to be on different areas of the roof. If this distance, so this S is what we were talking about before, is less than the S minimum that we saw on the previous slide, then the system has to be integrated some way into the PV, sorry, into the lightning, the PV system has to be integrated some way into the lightning protection system. The reason for this is if the systems are too close together, there is a chance of it arcing, right, and a spark forming between the two. And part of the lightning protection is also part of the fire protection. So if you think about before, it's protection of people and things, or people or property. So if they are too close together and there is no electrical connection, there is a chance of an arc forming and then something catching on fire. There is quite a few things that need to be considered or taken into account when connecting the two systems, or even just under the idea of connecting the two systems. Part of it is that if the PV system is connected to the lightning protection system, we need to ensure that there's no overvoltage through the DC cables that are going to run into the building. And the other part is if you decide not to include the PV system into the lightning protection system, then the whole system needs to be excluded. And so this is away from this S minimum value. And so that's not just the modules, but it's also the cable trays, any of the cables going into the building. All of this needs to keep that minimum separation distance. Right. And as with anything, there are also many other factors that can come into it as well. So if you do have metal roofs or metal in the insulation, also guttering or other cables that are on the roof as well, this all needs to be taken into consideration some way. So as you can see, there is a lot kind of going on, and this is why we keep going back to consult an expert if you are planning on integrating these systems. Jumping now to the internal lightning protection. So generally speaking, this will be some form of surge protective device, and so the SPD that we're talking about before. And there are two types, or actually two types of these systems. The first one, so SPD type 1, is a sort of a lightning current arrestor, which has the ability to dissipate the current, but cannot dissipate the overvoltages that may occur. We also then have the type 2, which works the other way. So if there is a voltage level difference, then it acts on that. However, it cannot discharge so much of the lightning currents. So, and then you can get some that are combined. And if you have multiple strings up on the roof, all of these will need their own SPD as well. So with this in mind, there are three examples that will generally occur. The first one is probably the simplest one, and that is if there is no lightning protection on the roof. Here we have a small diagram of a little pitched roof. Then there is no lightning protection that needs to be added. All right, so this jumps back to something we said earlier in the presentation, that the PV system doesn't represent an increased risk of a lightning strike occurring on that roof. So for a system like this, we'll have our our inverter in here, and we'll have a type 2 SPD on the DC side of it. And usually we'll have a type 1 or type 2 or a combination of it just above the junction box as well. So this picture is actually a little bit inaccurate. We would have this either down here or before grid entry. right? So if there is, just to manage that, the flow of energy from the house to the grid as well. You will also have inside the inverter some form of SPD as well. So depending on the inverter that you have, you might need sort of one in here, SPD in here as well, but this will change in situations, between situations. The second example is there is lightning protection on the roof. However, you can maintain this safe distance from the PV setup. And again, I probably shouldn't use the word safe, but you can maintain this separation distance from the PV system to the lightning protection system. And in this case, it does not need to be integrated, so there is no risk or very little risk of any arcing occurring. And in this case, the setup is very similar. So for the before you have the inverter, you'll have some form of SPD. Sorry, I'm showing you on the wrong screen. Before the inverter, you have some form of SPD, and then you may need one on the AC side as well, and generally speaking, one back towards the grid, whether it be to enter the house or on the other side of the junction box. And generally speaking, this will be a 1-2 combined. Right. Moving forward, the third setup that it could be possible is that you have lightning protection on the roof. You cannot maintain the distance from the PV setup. And so in this case, the PV setup needs to be integrated, right? And so this is where things change a little bit. And you'll notice now that we actually have SPD type 1 from the on the building entry side of the roof, so on the DC side of the roof, and you also have one down here as well, which is what we had before, but the main difference will be that we have the type 1 here as well. So you may also need a little bit of extra material as well on the lighting side of things in terms of the lightning rods, because we want to ensure that that protection area we were talking about before now covers the PV, but that may not be necessary, just depending on the project specific situation that you have. So you can have a system that is connected to you can have a PV system that is connected to the lightning protection system. And then the question arises, does this system, or do these components then need to be capable of carrying the lightning current? Right? Do they need to be able to discharge the lightning if there is a lightning strike? And the capability of this system, or the necessity of the system, depends on is that the primary task, or is that the task of the rails? Right. So if you have a situation where you have a lightning protection system and the lightning is designed, or the current is designed to go through the lightning protection system, then the rails themselves don't need to be able to take over any of this discharge. However, if you have a system where if you have a PV system that has been designed to be integrated with the lightning protection system, and the PV system must then take that discharge, in this case, then the rails must be able to do that purpose. Right? So it depends a little bit on what the system has been designed for and how the PV system has been integrated into the lightning protection system. So this is not to say that you can just use any product anywhere. You can do tests on your product. So if you're using our products, for example, the continuous rails, so these long rails that we talked about before on the classic system, these have been tested and these can take a discharge for lightning class, or one of the lightning classes. I had it before, but I don't have it down in my notes, sorry. maybe one of the guys can put it in the chat. But if you have a different system, uh, then it has not necessarily been tested, or it may be tested. You have to talk with your supplier about that. You could integrate it with the system, right? But only if you know that it's capable to be integrated with the system, if that makes sense. And if so, then if you're doing a plan in terms of like a large project as well, it can be beneficial to have this integration as long as it's capable of having the integration, because you can use the rails, they're usually quite long rails, to save on the aluminium that you would need to do the lightning protection system. So I realize that's my explanation there might be a bit back and forth, but in short, if the rails are required to carry current, they must be tested and must be capable of carrying current. If they're not required, then they don't have to be tested. That's it in short. So what are our recommendations for doing some form of integration, or when it comes to just lightning protection planning in total? First things first, and we've said it before, contact a lightning protection specialists, right? They'll be able to provide you with a project-specific information and provide you with all of the region-specific requirements as well. They will be aware of all of this. Regardless of that, though, there are a few things that you can say and tick off yourself that make it the first steps of ensuring that you have a safe system and you have an integrated system. So the first one being is, does the lightning protection work, or the lightning protection should still be working and fully functional with the addition of a PV system, right? You can also always ensure that the PV system is in this protection area, so it's not being touched by this giant ball rolling over the roof. And then you should be able to, or you should know that the minimum requirements for the mechanical material. So whether you're using the copper cable of 16 millimeters square or aluminium of a minimum of 25 millimeters square, this is something that you yourself can tick off and go, all right, yep, at least this has been done. In terms of the number and location exactly of where everything's done, this is where we recommend being in contact with the lightning protection expert. And one of the parts for back to the PV is that we can always ensure that there is the equipotential bonding between the components, right? So we've jumped a little bit from equipotential bonding to lightning protection, and here we're saying when the lightning protection is there and integrated with the system, you always want to ensure that that bonding is there regardless of any other comments of frame insulation or personal protection or anything like that. It's just a straight up equalize the system. So we've spoken quite a bit today about a range of topics, and you don't need to take a screenshot of this or anything, because as I said, we will send you the presentation from today. But these are some of the standards that we have used to put together this presentation. And as I said before, so this VDE is the it's the Verband der Deutsch, the Elektrotechnik, which is the German scientific association, which puts together the information which forms the basis of the German standards. All right, and so as I started at the beginning of the part today, that we encourage you to, if you are interested in this topic, look at your local standards as well, as they may differ from some of the information that we said today. Okay, so I think then we are pretty much finished with the presentation. I'll stop sharing. I would like to thank you all for joining. We had no questions that I see we need answered in the live part, so
I
that's
have no
good to
further
see.
questions to answer, Karen. And however, you're welcome to send us further questions later. think so.
Okay, absolutely. And so, as Martin said, if you do have any questions that has come up from the presentation or come up in the next couple of days or weeks, feel free to get in contact with us. Martin's probably direct email is the best place to go. So we might just put that in the chat now as well. If you have any questions on the topic, Martin put together this presentation and has been really driving this project as well. So we should also have a big thanks to Martin for helping with putting together this presentation, and he'll be able to get back to you as soon as possible. In terms of everything else, Nicholas, obviously, thanks to you for joining as well. I don't want to say that it was all just Martin myself. I know you contributed a lot to this as well, so I appreciate that. Klaus is behind the scenes and he makes it all work. And of course, a big thanks to you for joining us today. Before we go, there's another poll that's just popped up. We again appreciate the feedback. It helps us know who or how you thought today was, and hopefully we can give a better presentation next time. Speaking of next time, we have another webinar this time next week, which will be on tile roofs. It's a bit more of a general webinar where we're not going to go specifically into a topic so much, but we will be talking about some of our products for tile installations. And if you're new to K2, haven't used any of the products before, feel free to sign up for that. We would love to see you there. And I think then other than that, I do see two questions that have popped up. And yeah, we will just let them answer. So if you have questions in the next couple of minutes as well, feel free to put them in the Q&A section. The guys will get back to you as soon as possible. But if not, please consider this webinar finished. We will turn the camera off, or we'll put up a little screen, but we will hang around for a little while. So yeah, if you do have any questions, we can answer them. I think I've dragged on for long enough. Thank you Thank you everyone very much for joining, and hope to see you again next time. Ciao.